Welcome everyone to my presentation about how to architect for continuous delivery. First, quickly to myself. My name is Romano Roth and I'm the Chief of DevOps and a partner at Zühlke. I joined Zühlke 21 years ago as a junior .NET engineer. I became then an expert software engineer, then a consultant. And during that time, what was always at my heart is how can we continuously deliver value? How can we ensure the quality? And how can we automate things? And when the whole DevOps movement started, I jumped right on top of that and became one of the organizers of the DevOps Meetup Zurich, which is a monthly meetup we are doing. The next one is today about Ansible and about Postgres. And you are always free to join when you are in Zurich. And I'm also the president of the DevOps Days Zurich, which is a yearly conference we are doing in Switzerland. And the DevOps Days, this is a global movement in all big cities all around the world. There are DevOps Days conferences. And I'm, together with my team, are organizing the DevOps Days Zurich. The next one is on the 3rd of May. Unfortunately, it's already completely sold out. And as you can see, DevOps is really my hot topic. That's why I also have my own YouTube channel with over 100 videos all around the topic of DevOps, architecture, and leadership. I also post a lot on Twitter and on LinkedIn. And if you want to learn more about DevOps, then you can always join me on these channels. DevOps is also something that I'm doing in all of the projects. I work with different companies in different industries all around the globe and doing DevOps transformations. But what do I see when I join these companies? What I see is this picture here. The business, together with the clients, they have bright ideas. They plan together with them and they are putting these ideas into Word documents and into Jira tickets. And then they throw it over the wall of confusion to the development team. The development team looks at the Jira ticket and say, yeah, if you want to have that, then we can implement that. And they implement it. And then they throw it over the wall of confusion to the QA team. The QA team looks at the software, looks at the requirements, and they say, doesn't sound right, but they test something, it's green, and they throw it over the wall of confusion to the operation team. The operation team says, whoa, how should we operate that? That will never work in production. But somehow they manage to get it to work, and it goes back to the business, to the clients, and they say, what is that? That's not what we wanted. This does not solve our problem. This is useless. Sorry. And what you can see is this infinity symbol. This is a value stream. And we can clearly see that we are not organized across that value stream. We have these walls of confusion. And these walls of confusion, they are coming from the silo organization, which we are having. And when you look at these silos, they have different goals. So there is a complete lack of alignment. And what you also can clearly see is that there is a lack of excellence and especially a lack of software engineering excellence. And overall, we have a bad experience for all the people working in such a setup. Now, when we look a little bit closer where the root of that problem comes from, then we need to go back a little bit in history. First, we had the waterfall process where we planned, tested, developed, deployed, reviewed, designed, and launched big chunks of software. The scope, the budget, and the time was fixed at that time. And the problem was many projects were failing. It was a mess. And then some smart people in the year 2000 said, yeah, let's go agile. I think we need to deliver smaller increments of the software. This is how we can solve that problem. And this was a very good idea. It's a very good approach. Now time and budget are fixed. The scope is variable. But the problem is we are still working in projects. But our clients, they don't want to have a project. They want to have products. They want to have a service. Now, to understand that a little bit, we need to have a look at what's the difference between a project and a product. A project has a clear starting point and a clear end point. It has a set of resources, money and people, and it has a deliverable. These 10 features in that time for that amount of money. This is a project. So a project is about focusing on the output, maximizing the number of stuff that gets delivered. This is what a project is. On the other hand, when we look at a product, then a product focuses on the outcome. We want to solve the problem of the customer. We want to understand the customer need. We perhaps also want to adapt or change the behavior of the customer. This is what a product is all about. And in the product, we want to deliver that one feature that solves the customer problem. The customer does not care about these 10 features. He cares about that one feature that solves his or her problem. This is what the project, what the product is all about. And what helps here is DevOps, because DevOps is a mindset, a culture, and a set of technical practices, which provides communication, integration, automation, and close collaboration among all the people needed to plan, develop, test, deploy, release, and maintain a product. It's really about bringing us, working across this value stream and continuously deliver value. And you don't do that with a project, you do that with a product. This is why DevOps fits very well in the product thinking. And you already can see, we need to talk a little bit about the people. So when we talk about the people, we need to talk about the term DevOps. It is not very well chosen. It says development and operation. And of course, there are some smart people out there which say, yeah, nowadays security is very, very important. So we need to call it DevSecOps, which is development, security, and operation. And then there is another bunch of people which say, no. The business are the people who give us the money. So we need to call it BizDevOps, which is business development and operation. And you can already see all of these terms are coming too short, because in DevOps, we need all the people to continuously deliver a product, where we need a term like Dev, Sec, Bits, Arc, Comp, QA, Ops, and I'm pretty sure that I have forgotten someone. We can also call it DevXOps or DevStarOps, or we just call it DevOps, because at the heart, DevOps is about bringing all the people, all the process, all the technology together to continuously deliver value. This is what DevOps is at its core. Now, science has looked at DevOps, and I love the book Accelerate. It's absolutely amazing, an amazing book, and they looked in a scientifically way why some companies are very good at creating products and why some companies fail at that. And they were coming up with what you can see here with this picture. This is the core out of this book. And what you can see on the left side is, and you remember back, DevOps is a culture, a mindset, and a set of technical practices. These are the technical practices which are needed to achieve what on the right side? The mindset and the culture. And you can even see the interdependencies between these things and what leads to what. So, absolutely brilliant book. Now, many of you will say, okay, that's quite a cool thing, but what about the software delivery performance? We need some KPI to measure that this really works. And they also looked at that, and they looked at these KPIs. And just to say, it's not the velocity, it's also not the number of lines of code or the unit test coverage or anything the like. What science has found out is that there are the DORA metrics. There are 4 metrics how you scientifically relevant can measure software delivery performance. The first one is the lead time for changes. This is the amount of time it takes from the commit to get in production. And this is very important to understand, from code commit until production. The other part, the whole ideation part, is not in there. Why? Because it is statistically not really significant. And you cannot really measure that in a scientific approach. So there, the lead time for changes, the elite can do commits until production in less than an hour. This is also the benchmark. And the second one is the deployment frequency. This is how often an organization can successfully deploy into production. And here it is very important to understand that one of the fundamental principles of DevOps is that we distinguish between deployment and release. A deployment is bringing the code compiled or as a script into production with the feature toggle off. And the release is when we switch on the feature toggle and a user population can use this feature. This is the difference between that. And when you do that, then you can do deployments on demand, multiple deploys per day. And that's the elite level. Now, the third one is the time to restore a service. This is how long it takes an organization to recover from a failure in production. You can see elite is less than an hour. And the fourth one is the change failure rate. This is the percentage of deployments causing a failure in production. And the elite is between 0% and 15%. So these are very important metrics that you need to have. And when you now look at what the benefits are of DevOps, then again, science has looked at that. There is the State of DevOps report. They are doing that over 10 years. And they are always comparing the low performers with the high performers, with the elite. And here you can see the difference between low performer and high performer, so with companies which are not doing DevOps versus companies which are doing DevOps. Companies which are doing DevOps, they have 208 times more frequent deployments into production. They also have a 106 times faster lead time, so from code commit until something is in production. And they can recover from failure 2,604 times faster than companies which are not doing DevOps. This is due to the high automation part. And they also have a 7 times lower change failure rate. This is how many failures are going into production due to the deployments. And you can see this number comes from the high automation and also from the automated tests that they have, because you cannot only have such a huge deployment frequency when you are testing your code. Now, when you look at the report from 2021, then you see that everything is accelerating. So the whole market is accelerating. So the elite is even getting faster and faster. And when you now summarize this picture, then you can clearly see that companies which are doing DevOps, they have a faster time to market, more value for money, higher quality, and a higher customer satisfaction. So this is a very valid component when you want to architect for continuous delivery. So DevOps must be a part of it. Now, of course, doing DevOps is not easy. But when you want to scale DevOps up in a company, then there are some challenges. Let's have a look at these challenges. This is a picture that you usually see. You have different development teams, you have the wall of confusion, and you have different operation teams in companies. And when you then start to introduce DevOps, what usually happens, someone says, yeah, we need to have that DevOps thingy. Let's make a team that does DevOps. And then you have that bubble over there, which is just another silo that you are going to introduce, and you're not really organized across the value stream. Of course, this can be a first starting point to introduce DevOps, but you soon need to go away from that DevOps silo. What does it look like when you are doing DevOps at scale in your company? It looks like this, that you are bringing the development and operation, and here all the people are in there. It's just for simplicity reason that I just use the Dev and Ops term here. But all the people, you bring them together so that they can continuously deliver value, so that they are a cross-functional product team. This is how it then looks like, but there are challenges with that, because now each one of these teams is reinventing the wheel. You have a lot of inconsistency and redundancy in there. Also, some of the teams may have no or lack of operational experience, and you have a huge complexity in the tools. And another problem that I usually see is there is a huge discussion on whether you should go on-prem or in the cloud or both, and so on and so on. It's really a mess. But let's look at the tooling, because I think here it is worth to dive a little bit in, because this is what is sort of the fundament how you continuously architect for continuous value delivery. And you all know the term CI/CD, continuous integration and continuous deployment. But the problem is, this is only half of the truth, because in front you have the continuous exploration, so the ideation process, and in the end you have the release on demand, which is where you are going to switch on and off the features switches. And the whole thing is called the continuous delivery pipeline. And this is just an example how such a continuous delivery pipeline can look like. And you can already see that there is a lot of tooling in there, and all of these tools, they need to work with each other, and they also need to be maintained. That's quite huge. Of course, there are vendors out there which say, yeah, we handle that for you because we have the platform, GitLab, GitHub, Azure, DevOps. They say, yeah, we can handle everything. Yes, but when you take a closer look, you need to replace some of the inadequate parts. And also what you can clearly see is that some of these vendors are using also third-party tools. Of course, they are nicely integrated. Everything is okay. Very good integration points. And you can also integrate a lot of things. Nevertheless, the complexity of such a platform is quite high for a team. Now, when we want to architect for continuous delivery, then, as said, we need to architect this value stream, which you can see. And you remember back, I said DevOps is a mindset, a culture, and a set of technical practices. And when we now look at the technical practices which are needed to architect for continuous value delivery, then these are the practices that a team needs to adopt in order to continuously deliver value to the customers, so doing modern software development. And this is quite huge. Now, I want to also point out another thing. What I usually experience when I join clients is that I get onboarded, and the onboarding takes months. Up to 3 months until I have access to the systems which a company has. It's also I don't get real access. I always need to question things. I need to say I need there a little bit more access and there. So the onboarding is very, very hard. Also, when you look. Sorry. Also, when you look at when you want to order a new database or a new Kubernetes cluster or a new environment, it takes months until it gets provisioned for you. And also that is a huge problem. And when you get it, you need to configure it in the right way, and you need to go to some checklists. And then we just saw it. Also, security is a very important part. And of course, these platforms, they are solving you a lot of security issues, but going through all of these security vulnerabilities and making sense out of that is quite a hard thing. And even when you look at that, there is a real lack of standardization in there. And all over, you can see the cognitive load for the teams is very high. You get a very bad time to productivity. You have a slow time to market, and you have a low quality without any standardization. And this is a huge problem which we are facing. So now the question is, how to scale DevOps and architect for continuous delivery? Is that even possible? For that, we need to make a step back and look at the whole picture. What do we want to achieve? What we want to achieve is we want to create a digital factory. And in this digital factory, we want to have a conveyor belt where the value flows through, with a high degree of automation, so that we can focus on the real work. So this is sort of the target picture where we want to be. And how do we architect organizational-wise this thing? Is by introducing platform engineering. So we have the platform teams, so the product teams, so you have the product teams which work on the product. They have to focus on working on the product. They run the product and they build the product. So both, they also maintain it. In there, you also have the operation. It's not a separated team in that team. It's just for completeness. These people who operate it, or the team operates directly this product. In the middle, you have the platform team. And here it is important. This is not another silo. They are providing the platform, and the product teams are the customer. To understand that, we need to have a look at another picture. This is another view on the previous picture. You have the platform team at the bottom, which builds the platform with the CI/CD pipeline, with the API decoupling layer, with the Kubernetes, with synthetic test data. Everything is in there. And over there, on top of that, you have the product teams which are using this platform. So the product teams are the customer of the platform team. So the platform team develops, builds, and maintains this platform, which enables the product team to do DevOps, because then the product teams can practice DevOps and build and run and maintain their product using this platform. The product teams, they generate value for the customer, and the platform team generates value for the team. This is very important to understand, and this is how you architect for continuous value delivery. This means nothing else that, and I like this picture very much, that with platform engineering, you are enabling the product teams to do DevOps, and this is how you can scale, and this is also how you can make sure that the cognitive load on the teams is not so high. So what does that mean? When we look at what currently in companies, or what we are seeing in companies, is that we have a lot of walls of communication. It is because we are not organized across the value stream. We need to organize across the value stream, and then we need to go away from projects to products, bringing the customer in the middle. And to do that, of course, DevOps is a very good thing, because DevOps is a mindset, a culture, and a set of technical practices. But it is quite hard, and we can see that there is a lot of cognitive load on the teams. And here, platform engineering helps, because with the platform, we can enable the product teams to do DevOps. And what you can see out of that is that we are entering the age of industrialization of software development. And from that, you can see that this is the way how you can architect for continuous value delivery. Thank you very much. Are there any questions? I will quickly go to the chat.
Yes, thank you, Romano. I can pick some questions from the Q&A tab for you.
Yeah.
So,
cool.
Yes. So I think we had a couple of people asking, will the presentation slides be available? I'm just going to ask that out of the way first off.
Sure. Can I share that over this platform, or how can I share that with the people?
I'm not sure, but we can figure out somewhere. But like, just in short, yeah.
The most easy thing is just go to LinkedIn and write me a quick message, and I will send it to you. No problem.
Yep.
I will send it via LinkedIn, Twitter, or whatever social channel you have.
Yes. So slides available through Romano on LinkedIn or a platform of your choice. So let's see, what would be the questions here? One of the questions would be, can you name a few recommended SBOM generators? And somebody had said that they use Delphi as their code base and Jenkins for their CI/CD. So
I don't have any recommendation for that. I think SBOM is software bill of material.
Yes.
I must say I have not investigated that much or didn't went in too much into this, so I cannot answer here or give you any recommendation.
Yeah.
Sorry for that.
As far as like new topic, but
yeah, I know.
Fairly popular recently. And then there was a question from a certain Ville Vartiainen. So the pipeline architecture we saw around slide 23 has many different steps and different services. How would a team get started on implementing a pipeline like this?
Oh, very, very good question. So start small. That's the first recommendation. What you need to do in my opinion. There are two settings. One setting is you already are a value stream, or you are not yet a value stream. But what I usually do is I say, look, we are always a value stream. So let's think about what are the steps which are needed to bring an idea into production. And what I use here is the value stream mapping workshop. And this is absolutely no rocket science. You can read that on the internet. It is, you bring all the people together and you give them Post-its and you say, okay, now let's formulate all the steps which are needed to bring value until production. And you're going also to say who is responsible for that. And you're also going to measure the efficiency, but I will not go into depth of that. But in there, you will have the CI/CD part in there. And you will have certain steps like building, unit testing, and so on. The most important thing about the value stream mapping is that you have a clear picture about your value stream. So what steps are needed? And of course, when you have already a setup, then you will see all of the steps and you can think about, do we need to add or remove some of the steps, or can we merge some of the steps, or do we have bottlenecks in some of the steps? And when you are completely new, suddenly you have the picture and you know what you need. And in my opinion, you just go step by step. So the first step would be building up a Git repository. Second step, to build it, and then unit test and so on. So really go step by step. I also have a YouTube video, a step-by-step guidance, how to build up a DevSecOps pipeline with GitLab and with GitHub on my YouTube channel.
Fantastic. Next question is, what is your answer to companies insisting on ITIL processes?
Oh, the answer is quite simple. ITIL or ITIL is not a bad thing. But what they are doing is they have processes which are, of course, needed to deliver a certain business continuity. So it's a good thing. But the thing is, you don't need, some of these processes can be done by automation or are even redundant because you already have a tool that is doing that. And many people are thinking, no, you need to have that process, or you need to have that person doing that process, or we need to have that paper for that process. And the thing is, what you need to do is you need to look at the processes that are in place. You need to look behind the process. What kind of risk, because these processes are there to mitigate the risk. What risk are we trying to mitigate? And then think about, have we already, with our pipeline, mitigated that risk? And if yes, then of course this process in that context is completely obsolete and you don't need to do it. That's my answer to these companies. So yes, you need to have ITIL. It's a good framework, but many of the processes are redundant, or you don't need them anymore because you already have automated that with, for example, GitHub or GitLab or whatever you are using.
And then there was another question. Do you have a prediction for the 3 most popular continuous delivery tools in 23?
3. GitLab, GitHub, and sort of Azure DevOps. That would be sort of my prediction at the moment. Yeah, that's also why I have it on the slide. Of course, you can also use other tools like TeamCity or Jenkins or so. The problem there is more they are not sort of a platform. You need to stick it by yourself together. It's also a good thing to do that if in your case this is something. But I will go with at the moment with these 3 tools.
Yeah. Oh, well, the Q&A tab is like exploding right now. Hold on. Let me get a hold of that.
We have still some time.
yeah, exactly. This is a nice one, I think. How do you integrate threat modeling into CI/CD?
Threat modeling, not threat. Yes, threat modeling. Yes. Oh, a very good point. So, threat modeling is all about identifying the security threats. And the important thing about threat modeling is what you need to do is you need to architect for security. I always say you need to architect for security, you need to architect for testability, and you need to architect for operability when you want to do proper software engineering. So now let's quickly have a look at the architect for security. And this is done by threat modeling. What you're doing there is the following. You're going into a room and you are drawing the context diagram of your application, be that intranet or an internet application, and together with a security expert, and I always recommend to do that with a security expert, you're going to identify the attack vectors and also the threats that are coming in and the mitigations you are going to do. The mitigations which you come up with, they are going on the backlog. And then you are going to implement these mitigations. And you are going to test if these mitigations are really working. Second, in your pipeline, and this is also what my DevSecOps videos are all about, you are going to implement, for example, container scanning, software composition analysis, dependency scanning, and so on, SAST, DAST, and so on. And then when you are in production, you need to also continuously monitor the attacks which will happen outside, and this is how you do the threat modeling.
Excellent. There, another question. Sorry, these are coming like on production. Anyway, is the platform engineering team different from the DevOps engineering team, or is it a superset?
It's a funny question. I would say the DevOps team or platform engineering team, they are sort of the same. It always depends what that means in a context, or what they did in a certain context. But it's the same. In the end, the platform engineering team is nothing else than a product team, and they are delivering a product to the internal customers, so to the other platform. To the other product teams. That's what they are doing. So they are delivering also a product, and they are of course also doing DevOps inside. So they need to have software engineering skills. They also need to have testing skills, UX skills, all of that. So this is just a normal product team which is doing DevOps.
Hold on, that was hey. Oh. Hey, Cecilia. So there was another question. We still have time for a couple ones. When we divide teams into platform versus product plus DevOps, who is responsible for CI/CD pipeline setup and maintaining?
When you have that in a team, that's the question? Only in a team?
Well, yeah. So. When you have teams, but yeah, go for it.
Just read it again.
Yeah. When we divide teams into platform versus product plus DevOps, who is responsible for CI/CD pipeline setup and maintaining?
Very good question. Quick answer: the team. The team is responsible. The platform engineering team just gives the platform. Of course, they are doing also some consulting or helping the teams setting that up, but the team, the product team, is responsible for the platform, the CI/CD platform, for their product. Absolutely. But for the whole platform that this is working, is of course the platform team responsible.
I think final question still. Should the performance of the platform team be measured as developer satisfaction, and what would be good metrics?
Beautiful question. What I usually say, use the DORA metrics also for the platform team. I love these metrics. What I always add to the DORA metrics is the customer satisfaction, and also the employer satisfaction. And these are two things. So in the platform team, I would measure the employer satisfaction of the platform team itself. How satisfied are they with their work they are doing? And the second one is the customer satisfaction, and this is the platform teams, the product teams, which are using the platform, and also that should be measured. And then the complete normal DORA metrics, in my opinion. That would be the KPIs which I would use.
Okay, thank you, Romano.
Hi, we're from Efficode,
who brings you the DevOps Conference.
Continuous delivery has been a key focus for over a decade, and platform engineering is its natural evolution.
If you want to remove the pain and uncertainty from your software development, we'd love to help you.
Discover more at efficode.com
and enjoy the insightful sessions at the DevOps Conference.